The drain cleaner Drainex contains small bits of aluminium which react with caustic soda to produce dihydrogen. Now they're talking about Drainex, they're talking about caustic soda, hydrogen, aluminium. All that may look scary, but actually this has nothing to do with our problem. Let's read ahead. What volume of dihydrogen at 20 degrees Celsius and 1 bar will be released when 0.15 grams of aluminium reacts? Oh my God. Now they are reacting aluminium with NaOH, caustic soda, and they want the release of dihydrogen gas. They want to do calculations. This is gaseous state combined with mole concept. Unfortunately, you have to be aware of the equation. The first problem which you might encounter is that you don't even know which equation you have to write down. So let me write down the equation for you. If you do not know this equation, although this equation comes from inorganic chemistry, it has no relation with gaseous state or states of matter, you will be stuck in this question of state of matter. So they should have given the equation ideally. They haven't, because the NCERT being NCERT, they can do anything. So let me give the equation to you. It is NaOH plus aluminium plus H2O gives NaAlO2, sodium metaluminate. Very beautiful equation. Sodium hydroxide can dissolve aluminium, and this gives you 1.5 moles of hydrogen gas. Wow. This is the equation? Yes. And what data has been offered to us? I am given temperature is 20 degrees Celsius. That is fine. And 1 bar, pressure is 1 bar, which is also superb. And I have 0.15 grams of aluminium. Reacts. NaOH has not been given. Caustic soda is NaOH. Since nothing has been given, I assume that I have enough H2O and I have enough NaOH. How many moles of hydrogen I'll get? Now, using stoichiometry, I can calculate moles. But I'm given grams, and atomic mass of aluminium is 27. So this is 0.15 upon 27 moles. Since atomic mass of aluminium is 27, I have so many moles of aluminium. And if I have so many moles of aluminium, now 1 mole of aluminium gives me 1.5 or 3 by 2 moles of hydrogen. How many moles of hydrogen will be obtained? This 0.15 upon 27 into 3 by 2 moles of hydrogen gas would be liberated. Okay, how much is that? Well, this is 9 to 18, 0.15 by 18, 15 by 18, that is 5 by 6, 0.05 by 6. Make sense? Makes sense. So many moles of, this is 1 upon 120 moles. 1 by 120 moles of hydrogen will be released. Fine. Now, they have asked me the volume. I know the moles, I know the temperature, I know the pressure, and V, I remember, is nRT upon P. How many moles? I have 1 upon 120 moles of hydrogen. R. Now, what volume? Volume is usually, if you report it in liter, R is 0.0821 liter atmosphere per mole Kelvin. This is how you should record it with units. Temperature, 20 degrees Celsius is 293 Kelvin. How did you do it? Temperature in Kelvin is temperature in degrees Celsius plus 273. I just add 273 plus 20, that makes it 293 Kelvin. Units of Kelvin cancel. Please never substitute in degrees Celsius, that is wrong. Divided by pressure. What is the pressure? 1 bar. I have this in atmosphere. 1 atmosphere is how many bars? Now, 1.013 bar is equal to 1 atmosphere. So if you want, 1 bar is 1 upon 1.013. You could also use that, and roughly this is just 1 only. There's not much difference. Fine. What do? We calculate. How do we calculate? Let's see. This is 0.0821 into 293 into 1.013 divided by 120 liters. this is a calculation you need to make. Is it ugly? Whatever. It's not very pleasant, I must say. But once you do this, what do you get? You get the value as 0.2 liters or around 203 ml. This is the volume which you're going to obtain if you dissolve 0.15 grams of aluminium in excess NaOH as per this reaction.